Hello everyone, and welcome back. So far in this tutorial series, we have been exploring how to enable the OpenAI language models to use tools. We've looked at coding our own functions and getting AI models to use our code to expand its capabilities. OpenAI also offer their own built-in tools. These are tools which expand the AI's capabilities that are offered by OpenAI themselves. So far, we have looked at OpenAI's built-in web search tool, which enables the AI to search the internet to get live information for its responses. Today, we will be looking at file search and retrieval. We'll discuss what file search and retrieval is and when to use it. We'll also go through some code examples to walk you through how to upload your files and how to use the file search tool when interacting with your AI agents. As always, I provide free code templates and tools with these tutorials to make your life easier. Let's get started. What is file upload and retrieval, and when would you use it? So, OpenAI has trained its models on a large set of data. That large set of data contains almost all publicly written records up to a certain cutoff date. Outside of this training data, the AI models has no awareness of any additional information. That's why, in the previous tutorial, we looked at web search. This essentially enabled our AI to access data via the internet that was beyond its training dataset. We use file upload and search for a similar reason. Ultimately, we want to give the AI more knowledge and awareness of information that only we have access to. What I mean by that is this. Perhaps you run a business and you want an AI trained on your business. This means you need to teach your AI agent things like your refund policies, perhaps. You can teach your AI additional things like this by curating what is known as a knowledge base. A knowledge base is basically a written record of information that you need your AI agent to know for your specific use case, whether that's company policy or a research paper of yours, or maybe even your own study notes. To create a knowledge base, we can upload our files to the OpenAI server. OpenAI then create what is known as a vector store. A vector store is essentially a searchable knowledge base. It takes the text from all of the documents you've uploaded, breaks those documents down into smaller chunks, and indexes them in a way that allows OpenAI to quickly search for the most relevant pieces of information whenever a user asks a question. So, imagine a user asks your AI agent, "What is your company's refund policy?" Rather than reading every document from beginning to end, the file search tool searches the vector store, identifies the most relevant sections of your uploaded documents, and provides only those sections to the language model as additional context. The language model can then use that retrieved information to generate an accurate response based on your own documents, rather than relying solely on what it learned during training. This approach is known as Retrieval Augmented Generation, or RAG. Rather than trying to retrain the model every time you want it to know something new, we simply retrieve the relevant information at runtime and provide it to the model as context. Now that we understand what a vector store is, let's look at the code used to create one. This script will upload two example PDF documents to OpenAI. The first document contains a fictional company refund policy. The second contains a fictional company governance policy. We will then add both documents to the same vector store. This will give us one searchable knowledge base containing both company policies. Let's go through the code from the beginning. First, we import path from Python's pathlib module. Path gives us a convenient way to work with file and folder locations. We also import any from Python's typing module. We use this later when defining the structure of our documents list. Next, we import load.env. This allows Python to load environment variables from our .env file. Finally, we import the OpenAI client. We then call load.env. This loads the environment variables stored inside our .env file. One of these variables should be our OpenAI API key. We can then create our OpenAI client. The client will automatically look for an environment variable called OpenAI API key. This means we do not need to place the API key directly inside our Python code. Next, we define the location of our documents folder. We begin with the location of the current Python file. We then add a folder called documents to that location. This means the documents folder should be in the same project folder as our Python script. Inside that folder, we have our two example PDF files. The next section creates a list called documents. This list contains information about every document we want to upload. Each item contains two things. The first is the path to the document. The second is a collection of attributes describing that document. Our first document is called refundpolicy.pdf. We give this document a category of refunds. We assign it to the customer service department. We state that its intended audience is customers. We also give it a status of current. The second document is called governancepolicy.pdf. This document belongs to the governance category. It is assigned to the corporate department. Its intended audience is employees. It also has a status of current. These attributes are optional. The document could still be uploaded and searched without them. However, attributes provide useful structured information about each file. They can later be used to filter which documents are searched. For example, we could tell File Search to search only documents intended for customers. We could also restrict a search to documents with a status of current. This becomes especially useful when a vector store contains many different documents. You can think of it like adding metadata to the file search function. Next, we define a function called uploadFile. This function accepts the path of one local file. It uploads that file to OpenAI. It then returns the unique file ID created by OpenAI. Before attempting the upload, the function checks whether the file exists. If the file cannot be found, the program raises a file not found error. This gives us a clear error message containing the missing file's location. Without this check, it might be less obvious why the upload had failed. If the file exists, we open it using RB mode. RB means read binary. Files such as PDFs must be opened in binary mode when we upload them. We then use client.files.create. This sends the file to the OpenAI Files API. We pass the open file into the file parameter. We also set its purpose to assistance. Despite the name, files uploaded with this purpose can be used with vector stores and file search. Once the upload has finished, OpenAI returns a file object. This object contains information about the uploaded file. Most importantly, it contains the file's unique ID. The script prints the name of the uploaded file and its new ID. It then returns that ID from the function. We will use this ID to attach the uploaded file to our vector store. Next, we reach the main function. This contains the main sequence of steps performed by our script. The first step is to create the vector store. We use client.vectorstores.create. We give the new vector store the name Company Policies. Remember that the vector store will act as the searchable knowledge base for our documents. OpenAI returns a vector store object. This object includes the unique ID of the new vector store. The script prints this ID so that we can see which vector store was created. Next, we create an empty list called Files to Add. This list will eventually contain the OpenAI file ID and attributes for each document. We then loop through every document in our documents list. During the first loop, the script selects the refund policy. It passes the path of that document into our upload file function. The function uploads the PDF and returns its OpenAI file ID. We then add a new dictionary to the Files to Add list. This dictionary contains the returned file ID. It also contains the attributes we defined for that document. The loop then repeats the same process for the governance policy. After the loop finishes, both PDF files have been uploaded to OpenAI. However, uploading a file and adding it to a vector store are two separate operations. At this stage, the files exist within our OpenAI project, but they have not yet been attached to our searchable knowledge base. We do that in the next section. We use client.vectorstores.filebatches.create and poll. The vector store ID tells OpenAI which vector store should receive the files. The files parameter contains our list of file IDs and attributes. OpenAI then adds both files to the vector store as one batch. The create and poll method also waits for OpenAI to finish processing the files. This processing happens asynchronously. OpenAI needs time to extract the text from each document. It then breaks the text into smaller chunks. Those chunks are converted into embeddings. Finally, they are indexed so they can be searched. By using create and poll, Our Python script waits until this process has finished. Without polling, the script could continue while the files were still being processed. That could cause us to search the vector store before it was ready. Once processing has finished, the script prints the batch status. It also prints the file counts. The file counts tell us how many files completed successfully. They can also show whether any files failed or are still being processed. We then check whether the final batch status is completed. If it is not completed, the program raises a runtime error. This prevents us from assuming that our knowledge base is ready when indexing has actually failed. Finally, the script prints the vector store ID again. It formats the result as vector store ID equals the newly created ID. We need to save this value. In the next script, we will give this vector store ID to the File Search tool. That is how the tool will know which knowledge base it should search. At the bottom of the file, we have the standard Python main check. This checks whether the file is being run directly. If it is, Python calls the main function and begins the upload process. When we run this script, it performs the complete setup process. It creates one vector store, it uploads both PDF files, it attaches their attributes, it waits for indexing to finish, and it gives us the vector store ID required for the next stage. Our searchable company knowledge base is now ready. In the next section, we will connect this vector store to the File Search tool. We can then ask the model questions about the documents we have uploaded. Before running the upload script, you need to tell it which files you want to upload. To make this easier, I have created a simple HTML tool. You can download this tool alongside the code templates shared at the end of the tutorial. Open the HTML file inside your web browser. The tool begins with the 2 example documents used in this tutorial. You can remove these documents and replace them with your own. Enter the complete file name for each document. Make sure you include the file extension, such as .pdf or .txt. You can then add attributes describing the document. Each attribute contains a name, a value, and a value type. For example, you could give a document a category of refunds. You can add as many attributes as you need. You can also add additional documents by selecting Add Document. As you make changes, the tool automatically generates the required Python code. Once you have finished adding your documents, select Copy Code. Open the File Upload Code template shared at the end of this tutorial. Near the top of the template, you will see a comment showing where the generated code should be placed. Paste the code directly underneath that comment. Finally, place your actual documents inside the Documents folder. The file names inside the generated code must exactly match the file names inside this folder. You can then run the Python script to upload the files and create your vector store. In this Python script, we interact with a conversational agent which is able to search our files. This Python script follows the same template we have used in previous tutorials, except for at the top of the script, we define our vector store ID as obtained from the previous Python script. We assign it to the variable vector store ID, which we later use when we make our API call here. In the tools array, we define that we are enabling the File Search tool and which vector store ID we want to use. Now I can run my code and ask my agent questions specific to my fictional company. I can pretend to be a customer inquiring about how to make a refund, for example. And as you can see, it has responded, citing our customer refund policy document. You can download all of the code templates and tools shown in this video from my school community, the AI Workshop. The community is designed to help you learn how to build practical AI tools and automations using simple, step-by-step tutorials. Alongside the videos, you will find ready-made code templates, interactive tools, and downloadable resources to make each project easier to follow and implement yourself. You can also ask questions, share what you are building, and get help if you become stuck. Follow the link in the video description to join the community. Then, open the OpenAI API course and go to the File Search page. There, you will find this video alongside all of the code templates, tools, and resources used throughout the tutorial.